In this video, we are going to make the game ConnectFour. So to start, let me actually show you what the finished product looks like. So yours won't do this if you run it right now, but I'll show you what it will eventually look like. Here's ConnectFour graphics program. I'm going to run it. And you'll notice when I run this, immediately I just get a blank screen. So not that exciting, but it gets exciting when I start to click on the screen. You'll notice if I click, there's a checker actually dropped in the column where I clicked. And I can click here. Cool. Awesome. Looks like I'm kind of building something up. And you can see how this works as I keep going. And oh my gosh, look, red is the winner. My very exciting game against myself. So what are we going to do is we're going to code this game of ConnectFour. Now, this game of ConnectFour is broken up into two parts. If we take a look, there's two classes here. One is the graphics program and one is the game. The game is what handles the 2D array. And the graphics program is what handles actually drawing on the screen. So we're going to start in ConnectFour game. So I'm going to open that up. And you'll notice right off the bat that we have two different private instance variables. The first is called board, and board is a 2D array of ints. And the numbers that will be in this board is either 0 if there's no token there, 1 if player 1 is there, and 2 if player 2 has placed there. And that's important to know for later, this kind of 1 if it's player 1, 2 if it's player 2, because we're going to need to be able to check that to check if there's a winner. And then there's current turn number, which is who is the player who currently is playing their turn. So this will either be 1 if it's player 1 or 2 if it's player 2. These are our two private instance variables. They're going to kind of power this game. Now look, here's the constructor of the ConnectFour game class. And what's the job of the constructor? It's to initialize my private instance variables. And that's actually already done here for us, which is really nice. But we do have to do one thing, which is I need to fill in my board with values. So I'm going to fill it in with the values 0. And we're going to put 0 everywhere. Remember, 0 means there's no token in that spot, and that's how the board starts out, with no tokens anywhere. So to do this, I'm going to do my RC for loop. For int r equals 0, r is less than, I can just use rows and calls here since they exist inside of this method, so I can use rows, r++, and for int c equals 0, c is less than calls, c++. It's really important to know that I can use these variables here, again, because they're parameters to my constructor. But later on, when I'm writing the getWinner method, if I want to get the number of rows in the board, I'm going to have to do board.length. And if I want to get the number of columns in the board, I'm going to have to do board bracket 0.length. So I can't use rows and calls outside of this method. And then this is fairly straightforward. What I'm going to do is I'm just going to set this location to 0. So board rc equals 0. Sweet. So that's it for my constructor. Now it should be all empty. Let's skip over getWinner because this gets pretty complicated. And let's go down to the method dropChecker. And what this is supposed to do is basically drop a checker in the board. Now, I'm going to pop up this little example of a ConnectFour board, and we're going to talk about kind of what that would look like when I drop a checker in the board. If I drop one in column 4, like I'm showing here, it'll go all the way to the bottom. There's nothing in that column, so it will fall in row 6. If I put another one, it'll sit on top of that one that I just put, because there's already one there. And same thing, I put one in column 5, it goes all the way to the bottom, there's nothing there. And you can see that as I'm going through this, the checkers stack. Now, this doesn't really get interesting until I end up with checkers at the top, completely filling the column. Once I get here, what happens when I try to add another? It can't go in. Take a second and think to yourself about how we can potentially do this. How can we figure out which row the checker actually ends up in given the column that it's in? There's a few things that we have to think about. One being, what if that column is full? Then I actually have to return -1, so I will still need to do this at some point. And then the other, what is the first blank space? And really, in my mind, there's two ways that we can do this. The first is that we can do a for loop down the column. The start of the for loop would be empty if there were still empty spots in the column. once I reach a spot that has a token in it, then the spot above that is an empty spot where I can put the checker. That's definitely one way I can do this. Let's do that way first. And then I actually want to show you a different way you can do this. So here's what we're going to do. For int r equals 0, r is less than board.length. Again, I can't use row anymore, or rows anymore. R plus plus. I'm looping through the rows, and that will actually move me down one column because I'm not going to do a C for loop here, right? I just have the column I'm in. Then I can do this if board RC, if that bang equals 0, then that means I found a spot that has a token in it. What is the row that I end up in? It's actually the one above that. And this actually, sorry, this has to be call because there's no C, it's just this variable. So eventually I'm going to return r minus 1. If we're returning r minus 1, that's the row that this ends up in. We definitely need to change the value of the board at that location. Now, there's one little caveat with this that makes this problem a little bit tricky when we're looping forwards, which is what if this row was completely full? If this row was completely full, then board r call would not be 0 on the very first row, which would mean r is 0. So if I try to do board r minus 1 call equals current turn number, that could be a problem because if I do board of r minus 1 call and r minus 1 gets me a negative number, then I'm now trying to index into a negative number for a row in a 2D array. I'm going to get an index out of bounds error. So we really have to do something else here, which is if we want to do the forwards for loop way of doing this, I actually need to check first to make sure that the first row is not full. So I'm going to do this outside. If board 0 call bang equals 0, which would mean that this column is full, then we're just going to return minus 1. So now we actually don't have to worry about this problem where we would index into a negative number. And now I'm going to keep this return minus 1 out of here. We're pretty confident that then we've kind of covered our butts by doing this with always returning a number like Java wants us to, but it's never a problem to kind of keep it at the other one too. So now I've edited the board, I've returned the right thing. Before I do that though, I actually do need to change whose turn it is. If it was player 1's turn, it should now be player 2 who's up to go. And if it was player 2's turn, it should now be player 1. So I'm just going to add a little if statement in here that looks like if current turn number equals 1, then we're going to set it to 2. Else it was 2, so we're gonna set it to 1. Sweet. And this is kind of the forwards for loop way of doing this. Now, again, pretty big disadvantage of having to check this first to make sure I don't get an index out of bounds error. So let's try this the other way. Now, the other way, like I mentioned, is to actually start at the bottom of the column that you're looking at, and you loop up until you see an empty spot. And this actually solves the problem of having to check the index out of bounds error, because if you make it all the way through that for loop and you haven't found a spot that's empty, that means it's full and you can return -1 at the end. I also wanted to do this just to practice writing a backwards for loop, right? If we start at the bottom of the column, that's the last row, and we're going to have to loop up through row 0. It's been a while since we've done something like this, so I just wanted to review it again. So let's do a backwards for loop through all the rows, so up the column. Let's do for int r equals, we're going to start at the last row, so board.length -1 is the last row. We're going to loop while r is greater than or equal to 0, and instead of doing r++, I'm going to do r -. And what am I going to do? Similar code to what I had above, but now I'm looking for an empty space. So if board r call equals 0, then let's fill that in the board. So board r call equals current turn number. Let's switch the player whose turn it is. So if current turn number equals 1, then we set them to 2. This is probably a good candidate for copy paste, but I'm too far gone. Else current turn number equals 1. And then, of course, we can't forget return the row that we ended up in, which in this case is R. Now, this way of doing things was a little tricky just for this backwards for loop, but I think this actually ended up being a little cleaner than having to have this if statement at the beginning and then also looking at R minus 1. All right, so that's ConnectFour game. So I should be able to compile that. Hopefully there's no errors. Let's close out of that and let's now think about the graphics program. So let's look at the private instance variables for the graphics program. I've got game, which is a ConnectFour game. If I want to use any methods of the ConnectFour game class, I'm going to have to do instance.method, so game dot whatever the method is. I have a Boolean called game is being played, true if the game's still being played, and false otherwise. And then a color called current drawing color, which is actually, is the token I'm putting down right now red or black? And we're going to have to switch that back and forth once somebody makes a move. If you look up here, I also have a few constants like the number of rows and columns and the diameter of one of the pieces. All right, so let's go down here and let's write the method drawChecker, because eventually we're going to need to draw a singular checker on the screen, and it is kind of interesting to think about where that goes. So to start, a checker is going to be a G oval. So I'm going to do G oval checker equals new G oval. And the coordinates of where that goes are a little confusing, so I know we're going to put things inside these parentheses eventually, but let's do the rest of this first because it's a little more straightforward. I'm definitely going to want to do checker.setFilled true, and I'm definitely going to want to do checker.setColor to current drawing color. And probably once somebody has put a checker on the screen, it's now the other player's turn. So let's actually switch the current drawing color to the other color. So similar to the if statement I had in ConnectFour game. If current drawing color equals color.red, let's set that to color.black. Ooh, can't spell today. Otherwise, it was black, so we're going to set it to color.red. And very last thing here, always make sure we have to add checker. All right, now let's think about where this checker actually goes. The size of the screen actually represents the total size of the board, and that total size of the board is actually the number of rows by the number of columns times the piece diam. So when you drop a checker on the screen, each checker should be touching. The checker, if you drop in kind of column 0 on the far left, exactly touches the side of the screen. And same thing with the far column. And each checker is exactly touching. So if you look at the way that this works, if I have 6 rows, then I'm going to have 6 times 100 is actually going to be the height of my screen, since I can fit exactly 6 checkers in 6 rows. So each time I actually move over for a new checker, I'm actually moving over an entire piece diam on my screen. Now, it gets a little bit confusing when we're thinking kind of rows and columns for this, so let me actually bring up our little picture again. Remember that as I move and switch which column I'm in, what direction am I moving in? X or Y? I think clearly I'm moving in the X direction here as I switch columns. And as I move down rows, notice I said down, I'm actually changing my Y coordinate. So weirdly, even though rows are horizontal, when I change my row, I'm actually changing my Y coordinate. Columns are vertical, but when I change my column, I'm changing my X coordinate. So columns relate to the X coordinate and rows relate to the Y coordinate. So in here, this is what I'm going to do is we're going to type col. Whichever column I'm in is where this gets dropped. And remember, each time I drop it in a column, it's the top left corner, I move over one extra piece diam. So it's going to be col times piece diam, and then row times piece diam. And remember, it's then width and height, so we're going to do piece diam and piece diam. And there we go. There's our one checker, and it should be correctly placed on the screen. Now, when do I actually want to place a checker is when the mouse is clicked. So we're going to have to code this a little bit too. The first thing that we have to figure out when the mouse gets clicked on the screen is what column did the person click in? And now remember, if we're looking at this picture here, what column they click in actually depends on the mouse's X coordinate, right? As I move in X, look at me changing columns as I'm moving in the X direction. So let's do this. I'm going to say int call equals, it's going to have something to do with event.getX, the X coordinate. Now, if you look as I'm moving here, as I'm over here, I'm in column 0. If this was a full piece diam, that means anywhere within 0 to piece diam, I'm actually in column 0. Then anywhere within piece diam to piece diam times 2, I'm within column 1, and etc., etc. Which means that if I divide this by piece diam, that will actually get me the column I need. If you think about it, right? Piece diam is 100. If I put my mouse and click at 78, 78 divided by 100 is 0. That would put me in column 0. If I click at 342, 342 divided by 100 would be 3, which would give me column 3. So there's my column. Now, how do I get the row it was dropped into is, well, didn't I actually write a method for that in ConnectFour game? Oh, look. Here it was. It's called drop checker, and that returns the row where the column ends up. So I can do game.dropChecker row. And now, oops, this should be call. Takes the column as a parameter. Now that I know the row and column, I can draw a checker. So let's draw checker row call. All right, now we should be able to run this. Now, it won't exactly work. It's not going to say who won, but you should actually be able to drop checkers and they should kind of stack on top of each other. Oh, look at that. And notice if I get 4 in a row, it doesn't say I win. I can just kind of keep stacking checkers on top of each other. And that's because we actually haven't coded get winner yet. Let's do one more thing. Let's go up here, and actually after this while loop is what powers this, right? Hypothetically, as soon as I get outside of this while loop, I have a winner. Let's actually just put a label on the screen that says who that winner is so that you're able to check and make sure your get winner is working. So let's do this. G label, win label equals new G label. And let's have it say player plus game.getWinner plus wins. And let's just put that at 100, 100. Then let's do win label, or sorry, add win label. And now we haven't coded get winner, so this won't pop up until we do something within get winner. And that's what I'm going to leave to you. We are not going to code get winner together. I want you to code get winner on your own. And I want you to think about it because winning in ConnectFour is actually a little complicated. How do you win in ConnectFour? You have to get 4 in a row. But that 4 in a row can actually be horizontally, vertically, and then either the this way diagonal or the this way diagonal. To do get winner, each one of those is going to need its own RC cola for loop. So you're going to end up actually writing 4 separate RC colas as you're writing this method. Be really careful with index out of bounds errors, right? If you're checking 4 in a row horizontally, and you're trying to check me, the one next to me, the one next to that, and the one next to that, well, your for loop better be adjusted because if you're over here and trying to check the one next to you, that's going to cause an index out of bounds error. So hopefully you have a fun time writing get winner. It's a little bit tricky, but it's definitely some good practice in 2D arrays.